like we talked about, we found z already, and we found our x variable, correct? So do I stop after I find two variables?
No.
How many variables do I need to find?
3.
All 3. This is a 3-variable system of equations. I don't know why my screen is not following along. I'm on the previous slide. Let's pause the recording real quick. There we go. So like I said, we found our z, and we found our x. Now we need to find what? We need to find our y. So to find our third variable, we go back to one of our 3 original equations. One of these 3 original right here. What? Yeah, this is our first problem. Yeah, we can use our first equation. Everyone okay with the first one? Doesn't matter which one I pick. I can pick any of my 3 original. Okay, so let's use the first one. Let me rewrite it over here. 4x plus 2y plus 3z equals 12. So there's the equation I'm using. Wherever I see an x, I'm plugging in -1. I'm solving for y, so I just leave it as a y. Got to pause the recording again. Wherever I see a z, what am I plugging in? 2. That's what my z equals. That's what we got z to equal. So now I'm just working this out, solving it for y. What's 4 times -1? -4 plus 2y. What's 3 times 2? 6 equals 12. Everyone okay with what I've done so far? So I'm solving for y. What can I do from here? Huh? Can I do anything before I add 4 to both sides?
Oh, wait. Combine your like.
Combine my like terms. I've got a -4 and a 6 on the same side. What's -4 plus 6?
2.
So I get 2y plus 2 equals 12. What's my next step to get y by itself? Subtract 2 from both sides. 12 minus 2? 10. How do I get y by itself? Divide by 2 on both sides. So 10 divided by 2 gives me 5. So there's my y value. Whenever we're solving systems in 2 variables, then I want you to leave your answer like this. How did we write our answer with two variables? Put it as an ordered pair, correct? So in this case, since we have 3 variables, I want you to write your answer as an ordered triple. So it just goes in the order x, y, z. So what's my x value? -1. What's my y value? 5. And my z value? 2. So this right here in parentheses would be my final answer.
How would you graph it?
-1, 5, 2. Remember, the graph of these are these planes. So like I said, Thursday, I'm not going to make you graph these. That'd be very difficult. So I'm not going to make you graph them. We're just going to solve using substitution and elimination. Okay? Questions on this first example? All right. Ready for another one? Let's do it. Solve the system. This is good stuff. I know you guys love it. X minus 2y plus z equals -11. 3x plus 2y minus z equals 7. -x plus 2y plus 4z equals -9. This is my system of equations. I'm solving it. I'm trying to get my x variable, my y variable, and my z variable. My order triple that makes all 3 of these equations work at the same time. Okay? So, do you guys remember? I know it was back Thursday. What do I need to do first? What was my step one that we wrote down in our notes Thursday?
Subtract 2 of the equation.
Trying to condense my system in 3 variables to a system in 2 variables, right? By eliminating one of my variables completely to begin with. So let's check this out real quick. Let's check my x column. I've got x, 3x, and negative x. That might be okay to eliminate. I've got, in my y column, negative 2y, 2y, and 2y.
Yes.
That one's looking pretty appealing to me. And then z, I've got z, negative z, and 4z. Which one looks the easiest to eliminate twice? My y's. The reason we say that, they all have the same number in front of them, don't they? And when I'm using the process of elimination, my goal is to get the same number in front of that variable, right? That way I can add or subtract my equations to get rid of them. So let's eliminate our y's. Is everyone okay with that? So which 2 equations do you want to use first to eliminate y?
First and second.
First and second. So I've got x minus 2y plus z equals negative 11. 3x plus 2y minus z equals 7. Like we said, we're eliminating y. Do I already have the same number in front of it? Yes, I do. Do they have same or opposite signs? Opposite. I've got a negative 2 and a positive 2. Right? I look at the signs in front of the variables that I'm eliminating. So if they have opposite signs, am I adding or subtracting my 2 equations? Adding them. So x plus 3x gives me 4x. The y's are eliminated. What's z plus negative z? They get eliminated too, don't they? What's negative 11 plus 7? Negative 4. Does everyone see that? Can I now go ahead and solve this one for x? Yeah, how do I get x by itself here?
Divide by 4.
Divide by 4. What does x equal?
Negative 1.
Negative 1. I've already found my x variable. Everyone okay with that? Sometimes that'll happen. Sometimes you'll get 2 variables that eliminate. It happens. Okay. I got 1 equation. Now I got to get another. Now which 2 equations do you want to use to eliminate y? Huh? Number 2. So the second one. And which one? 2 and 3? Okay. Not the 2 I would have picked, but we can go for it. 3x plus 2y minus z equals 7. Negative x plus 2y plus 4z equals negative 9. I've already got the same number in front of y's again, don't I? Do they have same or opposite signs? Same. So am I adding or subtracting? Subtracting my 2 equations. Very good. I have 3x minus negative x. What does that give me? What? 4x? Because that would just become 3x plus x, correct? Now I've got 2y minus 2y. What happens with my y's? They're eliminated. See ya. Now I have negative z minus 4z. What did we say? Positive or negative 5?
Positive.
Negative 5z. Negative z minus 4z. And now I have 7 minus negative 9. What does that give me? 16. Very good. Question's how I got 4x minus 5z equals 16. Are we okay with that? So I've got 2 new equations now, right? I've got my x equals negative 1. And I've got my 4x minus 5z equals 16. I've already figured out my x variable, haven't I? Is there another variable I can find really quick now? How can I find z really quick now? Yep, I can replace the x with negative 1 because I know x equals negative 1. So 4 times negative 1 minus 5z equals 16. What's 4 times negative 1? Negative 4. Now I'm just solving for z. It's my first step to get z by itself. Add 4 to both sides. What's 16 plus 4? 20. Now how do I get z by itself? Divide by negative 5 on both sides. What does z equal? Negative 4. This is going a little quicker than that first one, isn't it?
Thank God.
Questions how I've gotten x and z so far? Am I done?
No.
Almost. What do I need to do now? Find my y variable. So which equation, which of my original equations, 1, 2, or 3, do you want to use to solve for y? Number 1? Everyone agree with number 1, or do we want a different one? Number 1? It doesn't matter. You can use either one. But we'll use number 1. X minus 2y plus z equals negative 11. We've got x equals negative 1. What did z equal? Negative 4. So I'm plugging negative 1 in for x, negative 4 in for z. And now I'm solving for y. What can I do here? Combine my like terms. What's negative 1 minus 4? Negative 5. Am I moving too fast for anybody? I can slow down if I need to. What's my next step? Add 5 to both sides. Negative 11 plus 5? Negative 6. And last step. Divide by negative 2 on both sides. What does y equal? 3. So what's my answer here? Very good. Negative 1, comma 3, comma negative 4. You do have to have your ordered triple in the correct order. Just like the ordered pair, it matters where each term goes.
So just
X always comes first, Y is in the middle,
so
Z comes
all
last.
the variables would be x, y, and z?
Yep.
Okay.
So X always goes in the first slot in my ordered triple. So X is negative 1. Y always comes second. Y is 3. Z always comes last. Z is negative 4. Always in that order. X, Y, Z. Everyone got it? Questions on the second example? We okay?
Yeah.
We sure? Are you okay? Okay. You said no, so I was checking on you. I'm worried about you. Can I move on to
Yes.
another example?
Yes.
You guys loving these examples? Yeah? I heard yeah.
Are we getting homework?
Yeah.
Can we get it now?
No. Okay. Solve the system. X plus Y plus Z equals 2. 5X plus 5Y plus 5Z equals 3. 4X plus Y minus 3Z equals negative 6. Okay. Once again, we want to write our three variable system as a system in 2 variables. So I want to eliminate one of my variables right off the bat. Okay, yeah, I'll wait. I'll wait for you to write. Sorry. I'm jumping ahead of myself.
You're so excited.
I'm so excited. Okay, let's look at our x column. We have x, 5x, 4x. Our y column, we have y, 5y, y. And z, we've got z, 5z, negative 3z. What do you think is going to be the easiest to eliminate? The y's. Why do you say the y's? Very good. I'm looking at it also, and I would think the y's are the easiest also. Two of them have the same number in front of my y. Right? So, let's go ahead and try to eliminate the y's. So which two equations do you want to use first? First and third. Okay. They have the same number already, correct? Yes. Do they have the same or opposite signs? Same. So am I adding or subtracting my two equations? Subtracting. So I have x minus 4x. What does that give me? Negative 3x. My y's eliminate. Z minus negative 3z. 4z. 2 minus negative 6. 8. Very good. Questions on how I got my first equation. Negative 3x plus 4z equals 8. There's one of my equations in two variables. I've got to get another though. I've got an equation in two variables. I got to get another one because I got to have the same number of equations that I have variables. Which two equations are we using now to eliminate y's again? We've already used the first and the third, so now I either need the first and the second or the second and the third. First and second? Okay, first and second it is. X plus y plus z equals 2. 5x plus 5y plus 5z equals 3. Which variable are we eliminating here? Nope. I'm eliminating y. Whichever variable I eliminated in my first set of equations, I have to eliminate that variable in this set of equations. Okay? So, do they have the same number in front of them, my y's? No, they don't. What do I need to do to make that happen?
Multiply the top equation by 5.
Multiply the top by 5. 5 times x? 5x. 5 times y? 5y. 5 times z? 5z. 5 times 2? 10. Do I have the same number now? Do we have same sign or opposite signs? Same. So am I adding or subtracting? Subtracting. 5x minus 5x. They cancel. 5y minus 5y. Canceled. 5z minus 5z. Canceled. 3 minus 10. Negative 7. If everything on the left-hand side canceled, what number does that leave me with? 0. Uh-oh. All my variables canceled out. I need to look at the statement that's left over. 0 equals negative 7. Is that true or false? That is most definitely false. Please do not say true. 0 does not equal negative 7. If I get a false statement, what's my answer? No solution. You guys probably like those, don't you?
Yeah.
That's the end of the problem. No solution. This is like one of those where all three planes do not have a point in common. They're either all parallel with each other, or two are crossing through one, or they're all crossing one somewhere, but they all three do not have a point in common together. Okay? So it'd be no solution. Questions on that one? Not too bad? Are we kind of getting it the more we do? The more problems we do, we're understanding it a little better. Break it down into a system into two variables. Solve for those two variables. Plug back in to get your third variable. Okay? I think I have one more example for you. Last one. Solve the system. X minus y plus z equals -3. X minus y minus z equals -3. 5x minus 5y plus z equals -15. Question.
So, could we ignore the whole bottom thing, whole bottom equation, and the z variable on the top two, and solve for our x and y first, and then plug those into the last one to get our z?
Wait, say that again? Ask me after the notes, okay? This is our last example.
Let me try.
Yeah, you try it out.
Alright.
See, tell me how it goes for you, okay? Did everyone get this written down so we can start going through it?
Yes.
Okay. X column, we've got x, 5x. Y column, we've got -y, -5y. Z column, we got z, -z, z. Which one's going to be the easiest to eliminate twice? Z. They're all the same number in front of the z, correct? Some of them have different signs, but that doesn't really matter. We're just worried about the same number, and then we'll worry about signs later. Okay? So which two do you want to use first? 1 and 2. X minus y plus z equals -3. X minus y minus z equals -3. We're eliminating z, correct?
Yeah.
So do they have same or opposite signs?
Different.
Different. So do I add or subtract? Add. Okay, I've got x plus x. What? 2x. -y plus -y. -2y. Z's are eliminated. -3 plus -3. -6. Everyone okay with how I got my first equation in two variables? 2x minus 2y equals -6. Is there any confusion on what we're doing there? Okay, which two equations do we want to use now? We used the first and the second one already. So now I need the first and the third, or the second and the third? First and third? Bless you. Z's already have the same number, correct? Do they have same or opposite signs? Looking at my Z's. Same sign. They're both plus, correct? They're both positive. If they're the same signs, do I add or subtract? Subtract. X minus 5x. -4x. -y minus -5y. What? Positive 4y. Z's are eliminated. Everyone see that? Any confusion there? -3 minus -15. 12. Questions there?
Nope.
Okay, I've got two equations and two variables now, correct? Now let's solve them.
We gotta get the variables.
Are we solving by elimination or substitution here? You can use either method. Which one do you want to use? Elimination. So I need either the same number in front of x or the same number in front of y. What do y'all want to eliminate, x or y?
Y.
Let's eliminate y. What do I have to do to one or both of my equations to eliminate y?
Times 2.
Which equation?
Top.
Second one.
No, the second one.
Multiply the second one by 2. 2 times 2x. 4x. 2 times negative 2y. What? Negative 4y. 2 times negative 6. Negative 12. Now I'm looking at this equation right here. This equation right here. Do the y's have the same sign or opposite signs? Different, opposite. So do I add or subtract them? Add them. Negative 4x plus 4x. Canceled. 4y plus negative 4y. Canceled. What does that leave me on the left-hand side? 0. 12 plus negative 12. 0. All right, my variables cancel each other completely out, correct? Do I get a true or false statement when that happens? True. 0 does equal 0, correct? So, it would be infinitely many solutions. I'm okay if this time around you put IMS. Infinitely many solutions. Everyone okay with that?
What is
Okay.
that?
What?
In between your I and your S.
M?
You mean pi?
Like a bin. Like a square.
Is that better?
Yeah.
Okay, so I get infinitely many solutions. Does that mean that every single order triple is a solution to the system of equations?
What?
Does that mean that every single order triple is a solution to the system of equations?
No.
No. It just means I have an infinite number of solutions, but it's not every single order triple, is it? So, there is a way to find the pattern of the order triple that would be a solution. So let's walk through that real quick. Oh yeah. So let's look at one of our equations in 2 variables. Which one do you want to use? Which one has smaller numbers? First or second? Second. That's got smaller numbers, right? Let's go ahead and solve this one for y. Let's solve it for y. So 2x minus 2y equals negative 6. Let's solve it for y.
What number is it? Oh,
Still the same problem. Still the same problem. How do I get y by itself here? Not yet. What do I need to do before I divide by negative 2? Yes? Subtract 2x from both sides. Now what do I need to do? Divide by negative 2. So that'd give me x plus 3. Y equals x plus 3. Everyone got that? Any questions there on what I've done? Just solved it for y. So when you do get infinitely many solutions, you do need to go ahead and do this. Find the description of which types of order triples are your solutions. Questions on our notes? Everyone good? Okay, we'll get the assignment tomorrow in class.
You're a beast.
No homework tonight. Any questions for me before I end my recording about the notes?